So now what we're going to do is we're given the equation, the function, and we need to graph it using the following transformations from above. So remember that when we're looking at our parent functions, there's two different types of table of values we want to start with. For the functions, we're going to use -1, 0, 1, and 2. And one function, we're going to use 0, 1, 4, 9. So when we are applying our transformations, we need to keep these two in mind. Remember, we only use the one on the right for the square root because those are perfect squares. So if we take a look at number 7, first thing is to identify the parent function. This is the square root because there's a square root symbol. So when I think about the square root function, the parent is just the square root of x. So since this is square root, I can't take the square root of negative, so that's where I'm going to start with 0, and I'm going to use perfect squares so that I can get nice numbers out. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So again, I'm just looking at the parent function. I'm going to go ahead and show this two different ways that you can apply the transformations to a graph. You can choose what works best for you. So I'm going to graph the parent function. 0, 0, 1, 1, 4, 2, 9, 3. Remember, with the square root, I can't go past 0, 0 for my parent function. So we start at 0, 0, and we go forever to the right. So here is our parent function. We need to now apply the transformations. So when we apply our transformations, we're going to go from left to right. So starting if there's something in front. There's nothing being multiplied in front, so I don't need to stretch or flip anything. Then I go to the right. I see this -3 on the inside. Remember, this is going to shift our graph right 3 units. So every point needs to go right 3 units. So starting with my 0, 0 point, I need to move it 3 spots to the right. That 1, 1 point needs to move 3 spots to the right, and so on. So if we do that first transformation, we would go over to 3, then that would move to 4, over here at 7, 2, and that one runs off the graph, so that's okay. So right now, just by moving it right 3, here is our new graph. All we have done is shifted every point right 3 units. Then if we keep going across, I now look at the end has +2. So remember, this is going to move our graph up 2 units. So I moved it right, and I'm going to go up 2. Move each point up 2 units. And now here is my graph. So if we look, and I were to write the ordered pairs of my new points, I've moved the entire graph right 3 units and up 2 units. So my new points are at 3, 2. That's at 4, 3. And 7, 4. That last one, we didn't have it ran off the graph, and that's okay. So if we were to think about how did we get here by moving right 3 and up 2, if we compare our values. So if I look at my starter point 0, 0, it moved to 3, 2. So how did we get from 0 to 3? We added 3. How did I get from 0 to 2? We added 2. Notice where that 3 comes from. It comes by moving right 3, and that 2 we got from going up 2. This will always be the case. So if I wanted to move my graph right 3, we would add 3 to our x's. So if I added 3 to all of the x's, we should get those final points, and that's where the last one comes to play. It would get 12. If we move it up 2, that affects our y-axis, so that's how we added 2 to get to our final destination points, and that last one would be 12, 5. So that's how we can get our final table of values, by applying the transformations to our table of values. So there's our final graph with the following transformations. I'll go ahead and show number 8 the same way, and you can choose if you want to stick with applying the transformations to the parent function step by step, or just use your table. So in number 8, if I look, this parent function is absolute value because it has the absolute value signs. So absolute value function, the parent, is just the absolute value of x. For absolute value, we are going to use the values -1, 0, 1, and 2. Again, for our parent, we just plug in our x's. The absolute value of -1 is +1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So we are just using our parent equation to find our starting table of values. So if we think about what this graph looks like, it should make a V. I get -1, -1, 0, 0, 1, 1, and 2, 2. So here is the parent. We're starting with the parent, and we're going to apply the transformations. So we start from left to right. So if I look first, out in front, we will see a negative and a 2. So this negative means my graph is going to flip or reflect across the x-axis. So if here's our x-axis, I need to flip everything over that. So instead of opening up, it needs to open down. 0, 0 is going to stay the same because it's on the axis. -1, +1 is 1 away, so it's going to go 1 below. On the other side, same thing. If I flip it straight across, here is my new value by just flipping it. Then we'll see this 2 that's being multiplied in front. Remember that 2, when it's multiplied, is a vertical stretch. So I'm going to stretch everything out by a factor of 2. This affects the y values, so I'm going to stretch it up and down. So normally, for our parent function, if I kind of graph it down here, when we look at our slope from our starting point to the next point, it's always up 1 over 1, 1, 1. But since I want to stretch it by 2 instead of going up 1 over 1, I have to go up 2 spots over 1 so that it stretches up versus having a slope of 1 between those first points. So that's what I need to do here. I need to, instead of having a slope of 1, 1 between my first 2 points, I need to stretch it by 2. So I need to go down 2 over 1 and plot my new point. Same thing on the other side. Instead of 1, 1, I need to go up 2 over to the next point so that it now has a slope of 2 and I have stretched it out. In other words, what we're really doing is we're multiplying those y values by 2. And you'll see how that happens over on our table of values. But we need to multiply the y values by 2 to make it 2 times steeper. So originally, this value was at -1. So if I multiplied -1 by 2, my y value should now be at -2. Same thing over here. Originally, the y value for this point was -1. To stretch it by 2, I multiply by 2 and goes to -2. Likewise, if I look at this additional point on the right side, the y value is at -2 right here. If I stretch it by 2 and multiply by 2, I should now go down to -4. So I need to put that additional point at -4, and I now have stretched it by 2. Last transformation is this +4 inside of the x. This is going to move our graph left 4. So from our newest transformation by stretching it, after we flipped, stretched, we now need to move it every point left 4. So starting with our 0, 0 spot needs to move left 4, and each additional point also has to do the same. So I go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and follow it over. Here is my final graph. So we flipped it to get to the yellow, stretched it by 2 to get to the green, and moves left 4. Our final one is this red graph. Now, how can we get it just by using a table of values? First thing, flipping it. So what we've done is we've flipped it over the x-axis. So actually, we've just taken the opposite of all of our y values. So over here to our parent function table. First thing is just we would take the opposite of all of our y values. In other words, we're really just multiplying them all by -1. Then to stretch it, we needed to multiply the y values by 2. If we do that, we would get -2, 0, -2, -4. Lastly, moving left 4, that affects the x values. So if I go left, I would need to subtract 4, opposite of what you think, to get -5, -4, -3, -2. Here should be our final points. There is the final graph that we should have. It's flipped over, it's stretched by 2, and moved left 4. So one thing to notice if you're going to use the table of values, whatever is inside with x is the only thing that will ever be applied to x, and opposite of what you think. It was +4, so we have to subtract 4 to x's. That's the only thing. We should only ever have one thing happening to x, and it will be opposite of what you think. To our y values, everything else outside of the parentheses will always apply to y. So -2 was multiplied out in front, so we would have to multiply that to the y's. If there was something added, subtracted on at the end, we would also apply that to y. So let's take a look at a couple more examples. The next one, number 9, we want to first look at the parent function. So since there's an exponent of 2, that tells me that it's quadratic. Remember, the parent function is just x squared. So the xy table for the quadratic, I use -1, 0, 1, and 2. I always use that except for the square root function. I can get the y values by plugging it in. -1 squared, 1, 0, 1, 4. I'm going to do this by just applying the transformations to the table of values. Again, quadratic we know should make a u, but if you want to think about that parent function, it starts 0, 0, and it curves up from here. So the first thing is I'm going to go left to right. So I'm going to start with out in front. I see this 3 that's being multiplied. That's going to stretch it by a factor of 3. So that tells me that I need to multiply my y values by 3. So that's the first thing we need to do. Multiply all of our y's by 3. I'll get 3, 0, 3, and 12. Next, we have the -1 inside, so that's going to move our graph right 1. Again, this is the only thing that will ever be applied to our x's. So we see -1 inside, so we're going to add 1 to all of our x's since it moves it to the right. So then we'll get 0, 1, 2, and 3. Lastly, the last transformation is this +2 at the end. Remember, on the outside, this is going to move it up 2. Again, this affects the y's going up, so then I'm going to add 2 to the y's to get my final points. 5, 2, 5, 14, and then bring down your x's as 0, 1, 2, 3, and we're going to go ahead and graph these final points. 314 runs off the graph, that's okay, we don't need it, we just need to know that it makes a U, so it's going to curve up on the right and curve up on the left as best as we can. And there is our quadratic graph. So it should look like it's moved right 1, it's moved up 2, and how we can tell about the stretch of 3 is if I look at the slope from the starting point to one of the next points over. I go up 3 over 1, so that's where that stretch of 3 comes into play. See if you can get the next one started and compare it to what we have. This one is the cubic function. So we start with the -1, 0, 1, 2. If I were to cube all those, I'll get -1, 0, 1, 8. There's only one transformation, and that's to move it left 2 because it's inside. So again, whatever's inside is the only thing that goes with x. So we subtract 2, and we get our final points. Here's our final points on the graph. Remember, cubic is a squiggle. So when we start with our parent cubic, we start in the middle, we go up on the right, down on the left. Hasn't flipped over, so we're going to do the same thing. Remember, our middle point is that 0, 0. So that's the one that we're comparing is right here at the -2, 0. So from there, I'm going to curve up through my points. From there, I'm going to curve down to the left. And there's our final function that has been shifted left 2. Go ahead and do the same. Let's take a look at 11 and 12 in a similar way. This parent function has a square root symbol, so it's the square root. Start square root of x. Parent function table. Since it's square root, we can't take square root of -1, so that's why we start with 0, 1, 4, 9 and get 0, 1, 2, 3 when we take the square root of those. Go left to right. The first thing is we have this negative out in front, which means it's going to flip everything. Again, anything that's on the outside goes with y. So, can do it different ways. If I'm going to flip it, I'm really just taking the opposite of all of my y values. In other words, the same thing as multiplying by a -1. So I could put the -1 there, we multiply by -1, or take the opposite. Then the next step is inside the +3 is going to move it left 3. So then we need to go and subtract 3 from all of our x values. We'll get -3, -2, 1, and 6. And then lastly at the end is this +1 moves that up 1, so it's going to affect the y values. So after we had flipped all of them, we're now going to add 1 to each of those. So we'll get 1, 0, -1, -2. Here are the final points that we're going to graph. After graphing our points, we need to know that the square root function starts at one spot and goes forever in one direction. So normally that starting spot 0, 0, it's now at -3, +1. So I'm going to start at that point, it can't go past, and I'm going to go down because we have flipped it. It should open down instead of opening up. This last function, because it has an exponent of 3, it's cubic. So parent function is x cubed, start with -1, 0, 1, 2, and if we cube them, we get -1, 0, 1, 8. It's our starting spot. First thing we need to do is the part in front, it's being multiplied. It's actually two different things. It's going to be flipped, and I'm going to stretch it. So in other words, I'm taking the opposite of my y values and multiplying them by 2. So we can actually do that all at the same time. Multiply all of our y values by -2 to get both the transformations of flipping and stretching. So we'll get a +2, 0, -2, -16. Then going left to right, inside we have -4, so it's going to move right 4. Again, inside's the only thing that will apply to x. Since it goes right, I need to add 4 to get 3, 4, 5, 6. And lastly, always last at the end, we need to go down 5, so subtract 5 from all of those y values. We'll get -3, -5, -7, -21. Keep the x's. And here are the final points that we need to go graph. Once we've graphed them, we now need to understand that cubic makes that squiggle. So normally, a cubic starts at 0, curves up to the right, curves down to the left. Normally, we start with that 0 spot. 4, 0 has now become 4, -5. So that's where we're going to start graphing this. But if you think about it, it's flipped. So instead of going up on the right, it's going to curve up on the left and curve down on the right. That last point kind of runs off the graph, and there's our final graph.